assume that maybe you don't know what blockchain is. You probably read about it or heard about it. And so if you're a blockchain expert, you might find this a little boring, but I'll just lay out the sort of details of the background of how blockchain works and what problem it solves, what are the use cases, those types of things. And then we'll look at 2 specific use cases from my students. Okay, so first off, so I'm at Concordia. I won't bore you with the details of my CV. I'll just say that I started working on Bitcoin a long time ago. It was about 50 cents a Bitcoin when we started doing research on it. And so we've done a lot of different things. In 20 minutes, I can't, tell you a lot about how it's going to work. But what I can do is I can point you at a really good course that was put together by some colleagues at Princeton University on Bitcoin. So if you get really excited about this and you want to learn more and dig into it, highly recommend this course. It's free. You can take it off of Coursera. You can just watch the lectures on YouTube as well. There's a textbook. The PDF of the textbook is also free, the preprint. I wrote the preface for it, and you can also get a paper copy if you prefer that as well. Okay, so why are we talking about blockchain? So you've heard of blockchain probably. You can go to your local bookstore, you can buy a book on blockchain, you can watch TED Talks about blockchain, you can pick up the New York Times and you can read about Bitcoin and blockchain, and it's well covered there. The price, the exchange rate of Bitcoin skyrocketed recently, so that generated a lot of interest in that currency as well. The exact relationship between Bitcoin and blockchain I'll touch on in a second. I've been using those 2 terms interchangeably, so I'll just say for now that blockchain is kind of the technology that underlies Bitcoin. It was invented at the same time as Bitcoin. It came from Bitcoin itself, and so that's why I'm talking about the 2 of them in the same breath. Now, a lot of industry is interested in blockchain technologies as well. So this is one project. This is the Hyperledger project. It was developed largely by IBM. It was turned over to the Linux Foundation, and not even all the companies fit on one slide. So you can see lots and lots of people are interested in this. You have technology companies, people in finance, and lots of different industries. Okay, so hopefully this has piqued your interest. So let's talk about what blockchain is. So what I'm not going to do is I'm not going to tell you how it works. Okay, we're going to just treat it like a black box. We don't know how it works. We don't really care how it works, but what does it actually do? What are the inputs? What are the outputs? What exactly is it all about? So the way I like to frame it is, before jumping to blockchain, I see blockchain as a kind of extension of what we might call the digital revolution. So we all know about, the digitization of different industries that traditionally were based on paper, and that led to a lot of efficiencies. I don't have to tell you a lot about those efficiencies. So let's just take one example just to kind of warm up. This is an industry that today actually still works largely on paper. So it's the transport industry. So let's say that there's some coffee and it's going to come here to Montreal where we are. Maybe it's coming from Colombia, and it's going to go across a bunch of, it's going to take a bit of a journey. So maybe this package lands in New Orleans, and when it lands there, there's going to be a port authority. They're going to fill out some paperwork. It's going to go across the US border, so there's going to be more paperwork. Then it's going to get shipped. Say CN is going to take this. They might ship it up to Chicago. There it will go through the shipyard. There'll be more paperwork. Then it will transgress the Canadian border, and eventually it's going to end up in Montreal. Okay, so digitization is just this idea of, we have this big sack of paper, and my understanding is that for a typical good like this, it could be a stack of 200 pieces of paper or something like that, 200 forms. So large amounts of forms. What we're going to do is we're going to put it in a database. Okay, that's digitization. Now, once it's in a database, we can have a bunch of people that are going to read from this database. They're going to write to this database. If you need to know that information, if you want to make sure that all the forms are complete, if you want to go dig out the 50th form in that stack of 200 forms, you can do that. Okay, so this is what digitization does. It gives you all of those efficiencies. But digitization introduces one new problem. There's one key new problem that we didn't have before we decided to digitize this. And it's not a security problem. Okay, we will talk about security in a second. But the problem here is more of a political problem. It's a governance problem. The problem is who actually owns this database? Who's the entity that's going to put it up? So let's go back to our example. These goods are going through shipping yards, they're going through rail companies, they're going through governments. So who's going to put this database up? Is it going to be the US government? Well, the Canadian government might not like that. If it's the Canadian government, conversely with the US government. Is it the shipping yards? Well, CN might not like it. Maybe CN itself puts it up, but then are the governments going to write into CN's database and access it? Now, all of these entities might have their own databases. That's fine. That's still some extent, there's some digitization, but you don't get that net benefit of having all that information in one particular place. So databases, when you introduce them, they create problems. They create this governance problem of who is it that owns the database. And once you own the database, you're in a kind of privileged position where people are coming to you, and so you can turn access on or off. One database that we have here in Canada is say, if you've bought or sold a home in recent times, there's a big database called MLS. And so MLS changes the rules. Sometimes they only let real estate agents that are licensed be able to list homes. Then maybe they're going to let private citizens list homes, but they're going to have to pay a fee. And so every time they change the rules, different people get upset. Right? There's different stakeholders that get upset. So that's an example where there's a certain amount of power that comes from being that one entity that is actually maintaining the database. You have some logistical problems. So you have to make sure that the data is always available 24/7. It's not going to get hacked. It's not going to get leaked if it's private data. You're going to have to decide who has access and who doesn't have access. So this is where blockchain steps in. What blockchain is doing at the highest level is it's actually trying to solve this particular problem. Now, actually, let me back up 1 second. There's one other property that I really want to highlight because I think it's a key problem as well. Anytime you write into a central database, what ends up happening is there's two copies of your data. There's your local records, and then there's the records in the database. And you need to make sure that those match. So for example, banks, when they send money between themselves, they go through a database style system called the Large Value Transfer System run by Payments Canada here in Canada. And so the banks will spend a lot of time doing what's called reconciliation. One bank will look at all the payments they made to another bank, then they'll go to Payments Canada and make sure that that number is the same, that it adds up. And if it doesn't add up, then they have to figure out where the error is. And so all this reconciliation is also very, very costly. So can we do better? So this is the idea of blockchain. The idea of blockchain is that instead of having this one database, we give the data to everyone. So everyone has a copy of the same data, and they all talk to each other. So we get rid of the database in the middle. And now we have a network of participants that are going to share all the data between them. Okay, so why does this help? Well, it helps in a bunch of different ways. So the first thing is you don't have this governance problem. Who's going to put the database up? No one's going to do it. They're just going to talk to each other. Okay, so CN will have their own data and the government will have their own data, and they'll all be nodes on a particular network, and they'll all be part of the same data sharing protocol. The next thing is that this is really what the core technical contribution or the security contribution of blockchain is. What it allows you to do is it allows you that when you look at your copy of the data, you can be sure that everyone else has the exact same copy. So this is sometimes called consensus. It's been studied in distributed systems for a long time. Blockchain has a novel solution to this particular problem. That's the academic contribution of blockchain. It also gives you security properties. So let's say that nodes are dishonest. So they're going to lie about the data that they have. They're going to try and get those lies replicated across the network. Maybe they just go down because they're not available. Whatever the case is, the network's going to be resilient to these changes. Now, if everyone on the network is malicious, then the network can't do anything about it. But in general, you can think, kind of roughly speaking, that as long as a majority of the nodes are sort of behaving correctly, then the network will behave correctly, and all this data will be exactly the same across nodes. Okay, now because there's no central database, your local data is the same as the data, right? When you look at your local records, the local records is what's in everybody else's records. So there's no more reconciliation. If you want to know what the network thinks that your transactions are or what your balances are, you just look at your local copy and you know that that's replicated across the network. Because of this replication, you also have redundancy. So the data is stored in lots of different places. So if people go offline or there's power outages or that type of thing, the network's resilient to it. And then the key property is that blockchain can do a lot more. So what we've been talking so far is we've been thinking of blockchain sort of as a database for storing data, for storing passive data. But what a blockchain actually does is it can actually run processes. It can run code. It can do little tasks. So what you can do is you can tell the blockchain that when you see data and it looks like this, or it comes from this person, or whatever the rules are, as long as you can code it up, then the blockchain can do a task when it sees that data. And all the nodes will do the task as well. And they'll all make sure that they get the same answer, that the outcome of the task is exactly the same. And then once everyone's agreed that the outcome of the task has been decided, then they'll write that outcome to the blockchain. And then they'll move on. They'll wait for new inputs, and then new inputs will come and they'll repeat that process. So we sometimes talk about smart contracts. That's the terminology that's sort of used in the popular literature. So if you've heard that term, that's what this particular process is. And so this idea of a blockchain running code, not just being a passive store of information, which it can do that very well. But this idea of having actual active processes that run, that's what gets people most excited about blockchain. And so they try and look for lots of different use cases. And so here's a list. I'm not going to go through all of them, but there's millions of things that have been proposed. A lot of them revolve around finance. So our own personal research agenda is largely centered in the financial industry. I like finance because it's kind of 1 degree removed from currency. Blockchain did work for Bitcoin. So that was the first successful application. So because it works for Bitcoin, we think it's probably most likely to work for other financial applications. But people have looked a little further away from finance. So Masa, for example, will talk about how blockchain could help in SSL certificates. Government is interested in it, things like voting. People have proposed it for managing different types of data. It could be binding cryptographic keys to identities or know your customer compliance for financial information. We've done some work on just fun applications in terms of gambling, prediction markets, and those types of things. Now, in each of these cases, you can look at them one by one, and to a certain extent, you can kind of make an argument about why blockchain might be a more useful solution, or it has some advantages over not using a blockchain. If you don't use a blockchain, usually you're going to use some sort of database, or you're going to have a system of databases. That's the alternative world. But the big advantage that most people who study blockchain isn't that individually, case study by case study, blockchain is superior to the database approach. The thing that gets most people excited is that in this case, once you get one of these use cases on a blockchain, then you can have other use cases on the exact same blockchain, and then they can start to interact. So for example, let's say you're doing something that involves, say, transfer of land. Well, if you have payments that are also on that blockchain, then you can do the payment side of that as well. Maybe you have insurance that's also on that same blockchain, and so that can get tied in. And so you can bundle together all of these applications. And so it's sort of that cross-layer approach, or the interactions, the interoperability of all the different use cases on the same blockchain. That's where most people are excited about this technology. Okay, now when I talk about blockchain, there's always a couple questions that come up. And so I thought I would just give you a quick summary of the standard ones. So the first one is, what does the term actually blockchain mean? Different people, depending on who you talk to, are going to use that term differently. So some people who are on the technical side, for them, a blockchain is only the blockchain that's inside of Bitcoin, and anything else isn't a blockchain. Other people will use the term blockchain to refer to any kind of idea of this distributed ledger. So the high level picture I showed you, where you have nodes on the network and they all have different, they all have the same copy of the same data. you can think of that as a distributed ledger. And so anything that gives you that distributed ledger, even if it looks completely different than how Bitcoin implements its blockchain, they would consider that a blockchain. And then sometimes you hear kind of more at the executive level, people will just use this idea of blockchain as kind of like this idea of digitizing different industries. So if you think of Bitcoin at a philosophical level, it took kind of a paper-based currency and made a digital version of it. And so sometimes people just use that term. I don't care how you use the term, you can use it any way you want. But the main point is that when you're having a discussion with someone else, I've seen a lot of arguments break out just because different people have different definitions of what this term is. So it's good to standardize your terminology. The other thing is that blockchain is very closely related to databases. I would actually consider it a subset of databases. So we should talk a little bit about what's the difference. What is it that a blockchain solves that a database doesn't solve? In particular, you could have a distributed database. So we have this idea of distributing data across nodes. So that looks very different than a central database. But we also have distributed databases. So what's the difference here? So the way I see it is I see it as kind of, and the emphasis is on different things. When I think about a database, first off, I think about storing lots of data. I think of big data. Blockchains are not for big data. Blockchains for very small data. For example, Bitcoin's blockchain stores 1 megabyte every 10 minutes. So if you have a music file like an MP3 file, that might be 5 megabytes. So it might take you an hour to put a song up on Bitcoin's blockchain. So it's not for large data at all. The other thing I think of when I think about database research is you have this large data. Now you want to do some sort of complicated query, right? You want all the records that match, this criteria and this criteria and this criteria or this criteria. And you want the database organized in such a way that you can quickly retrieve that information. So there's a lot of emphasis on storing the data in a particular way so that you can handle a complex query. In blockchain, there's no query. There's actually only one thing you can ask a blockchain, which is give me everything. Give me the whole database, and then you get it. Okay, so blockchain is not for big data. It's not for complex queries. What is it for then? Well, what it's for is when you write data to a blockchain or you ask it to do a task, it's going to be validated. Every node is going to look at that data. They're all going to decide whether that data is valid or not according to some rule that you write. You can choose the rule yourself. So if it's a currency, it might be that I'm trying to send Shirley money, and so I actually have the money to send to her, right? I'm not trying to send it to both her and to Masa at the exact same time. Okay, these are what rules might look like for a currency system. Your system might have totally different rules. But the point is that the network is going to enforce those rules. Okay, so it's small data, but everybody on the network looks at the data. They all apply the rules to the data. They apply the tasks that are supposed to be done in response to that data, and they all agree on the same outcome. They all agree that this is valid or this is not valid, or the output of this task is exactly this. Okay, so that's what you get with a blockchain, is validated. And even if you have nodes that are malicious, that are trying to disrupt the process, right? They're trying to take the money that I'm trying to send to Shirley and they're trying to take it for themselves. Even if you have nodes that are trying to do everything wrong, the network's going to be resilient, okay? So it's still going to perform correctly even in the face of a malicious adversary. Okay, the other thing that sort of in the frequently asked questions, everyone asks about the energy costs, and you read about Bitcoin consuming a lot of hydro, and there's a lot of confusion about where that comes from. Why is it that Bitcoin consumes a lot of energy? So this is where it comes from at a high level. In Bitcoin, or in blockchain in general, we talked about how all the nodes have to agree that the data is correct. Okay, so when they see something, they have to agree that it's valid or what the output is of a rule that's applied to it. So how do they do it? Well, at the highest level, they just sort of vote. Okay, so some nodes vote yes, some vote no, and you take a consensus of the network. Now, voting is a little more complicated than it seems. It kind of glosses away some details. So the question is, anytime you have a voting system, it's one vote per something. Right? So in a network, in a blockchain network, what is it? Is it one vote per computer? Okay? It could be one vote per computer. That sounds really, really great, but how do you measure the number of computers? if I join the network, I can make my computer look like 1,000 computers, and then I get 1,000 votes, right? Are we going to do it based on IP address? How are we going to ensure that it's just one vote per computer? So Bitcoin's contribution was, they said, well, this is what we're going to do. We're going to make you run your computer at full speed, as fast as you can, okay? And if you want to make your computer look like 1,000 computers, you're not going to be able to run that computer 1,000 times faster than you're currently running it. Your only solution is actually to go out and buy 1,000 other computers so you can run 1,000 times faster, and then you actually are legitimately now 1,000 computers instead of one computer. So what they did is they took this idea of voting based on computational abilities. So the more computational ability you have, the more votes you have in this sort of consensus protocol. Okay, so this isn't exactly precise, technically precise, but this is the sort of essence of what Bitcoin does. Now, no one votes through computer power anymore. We now use chips that are specialized for this particular purpose. But this allows Bitcoin's blockchain to operate on an open network like the internet, where you have no idea who's joining your network, who's leaving, how many computers they have, or anything like that. Finally, I'll just note some relations to Bitcoin. So we talked a lot about Bitcoin throughout this, but I'll just say a few things. So Bitcoin is the first application of blockchain. It's where blockchain came from. It's a digital currency. We have digital currencies. So for example, you can email money in Canada from bank account to bank account. That's not a true digital currency. What's happening there is kind of smoke and mirrors. You are authorizing the bank digitally to send that money, but the money doesn't actually move when the person receives the email or they click the link to deposit it. It looks like it moves because your checking account goes up, but it's actually a form of credit that's being fronted to you by the bank. And then there's this big settlement process that takes 1 day, at least for banks. And then if it's an international payment, it could take 3 days. If it's any kind of stocks or derivatives or that type of thing, then it could take 3 days as well. So all the settlement and clearing that happens behind the scenes, you don't see that. It's a sort of magic trick where all that's hidden from you, but really that stuff is taking days to do. In Bitcoin, but with Bitcoin by contrast, once you send the money, it's there. Okay, so it's 10 minutes later, it's settled and it's cleared. The other thing about Bitcoin is that there's no central party that runs it. Because it's a blockchain-based technology, there's no center database, there's no company behind it, there's no one person that's in charge. It runs completely on an open network, a network that you could join yourself. And in terms of issuing new Bitcoins, the protocol issues it itself. So there's an algorithm that decides how new Bitcoins come into circulation, and there's no sort of central bank or some entity that's deciding who and when these Bitcoins come into circulation. This is sort of what Bitcoin looks like. So it looks like you have a wallet that's on your phone. You go to a website, maybe all the information's in a QR code, you sort of scan it, and then you authorize the transaction. How do you actually get Bitcoin in the first place? So traditionally, you use a website that's set up like an exchange service. It's kind of like buying stocks. There's an order book. You can see what people are willing to buy or sell Bitcoin at in terms of Canadian dollars or whatever your local currency is. You can also use ATMs. So a lot of countries have ATMs where you can walk up and buy Bitcoin, or in some cases, you can even sell Bitcoin for your local currency. ATMs tend to have higher fees, so most people use exchanges, but it is a possibility. Okay, so anyways, that was a sort of whirlwind tour of Bitcoin blockchain technologies. Now what we'll do is we'll look at two specific use cases. So Masa will go first. She'll talk to you a bit about one project we did for SSL certificates on Ethereum, which is a particular blockchain. And then Cheyenne will talk about cryptojacking, which is doing this proof of work process on people's computers, kind of maliciously, but he'll add a little nuance to it.